So the example we're going to use next is autosomal dominant. And we're going to use a heterozygote versus a homozygous recessive. Now the story changes here. And I am going to use a real world example for this one. It's a little bit more relatable, I think. We are still working with an autosome. I just want to point this out because next, like in the next example, we're going to start working with X-linked traits, and I want to make sure that we are clear on this. It is still an autosome. It's still one of those 22 autosomes. Therefore, your sex does not actually play into this particular scenario. All right, autosomal dominant. We're going to do a heterozygote crossed with a homozygous recessive. Okay. So for autosomal dominant, and we're doing a heterozygote crossed with a homozygous recessive. Go ahead and fill in the letters that you think that it is. Don't overthink it. Heterozygote crossed with a homozygous recessive. And let's use the letter H. Sorry, I should have told you that ahead of time. Let's use an H. So this is what I have. Does everybody agree? Small h, small h. Now in this case, we are going to use a disorder called Huntington's disease. What does the small h mean? If the large H means you have Huntington's disease, what does the small h mean? That you don't. You notice how it starts to change a little bit. So go ahead and set up your Punnett square. Don't overthink this part of it. Don't try to predict the story, for example. Just set it up as you were before. You have a heterozygote. You set up an H, small h, and a large H. You have a homozygous recessive. You set up a small h and a small h. Go ahead and fill in your Punnett square. Does everybody agree with my setup? Check your answers before you fill it in. It gets messy if you get them wrong. Make sure you're setting it up the same as me. Yes? Go ahead and do your phenotypic and genotypic ratios. In this generation, how many of the four are going to have a big H, small h? And how many are going to have a small h, small h? What is the ratio between big H, small h, and small h, small h? What is the ratio? Big H, small h versus small h, small h. What is the ratio? Yeah? 1 to 1. Don't overthink it. All right? So it's actually the same one I think that we just worked with. It just, the outcomes are very different. So the next thing we say is phenotypic ratio. Which individuals actually exhibit this trait? Which individuals exhibit Huntington's disease? A or B? A or B? Everybody agree? A? So this individual expresses the trait. That is a dominant disorder. And then individuals who have a small h, which is a homozygous recessive individual. In this case, the whole thing is turned around, right? The homozygous recessive is the only person who is spared the disease. And then the medical ethics question comes along. If you have a parent who exhibits Huntington's disease, chances are very good they are a heterozygote. It's such a rare condition that it would be unusual for anyone to be like this, right? That, I mean, like, it doesn't happen. It's very, very rare allele. It's a rare mutation. So if you have this, if your parent is a heterozygote and therefore has Huntington's disease, you have to think about whether you want to get tested for it. Because it turns out that Huntington's disease, you can live for 35 years of your life without ever knowing you have it. At about the age of 30, 35, you start to exhibit what kind of seems like schizophrenia. And by about the age of 50, 55, you are basically catatonic. The movement is gone. It's freezing. Parkinson's is one of those where your movements are a lot. Huntington's is a freezing of movement. So the question in a medical ethics class would be, would you want to know? Would you encourage your patient to find out? What do you think? How many of you would want to know whether you have, let's say your mother has Huntington's, which means that you have a 1/2 chance of actually having the disease, but you won't know for 35 years. You could live a full life. What do you think? How many of you would want to know? How many of you absolutely wouldn't want to know? Okay, so there's always some students who don't want to know. There's always some students. You think about your own progeny, of course. You think about whether you'd want to pass it on and so on like that. So, all right. So that is an autosomal dominant disease. That's a good example of an autosomal dominant disease, or an autosomal dominant trait, I should say. Questions?